Okay, good afternoon. So last time, if you remember, we talked about a theorem. So let me also show you the theorem here. So this was our theorem. So we actually had that function f of x here, and then equals to integral from a to x f of t dt. And then we'll learn that under those conditions expressed in this theorem, which is called the first fundamental theorem of calculus, the derivative of this function is very easy to calculate. Yes? So what you need to do is just to write the little f, which is the integrand function here, and then replace t with x. Yes? So that was the fundamental theorem of calculus, the first one. And then we didn't talk about, because I received some questions, what happens if x is the lower limit rather than a, or what happens if I have something which is not x, then what happens here, okay? So this is recording, yeah? Okay. Yeah, anyway. So this is the one, this I want you to know as well. So what happens if I have g of x on top rather than just x, and what happens if I have two functions h of x and g of x for my bounds, yes, for my limits of the integral. And that is actually nothing except the chain rule. So I just want to motivate you, this is just the chain rule, so we can combine them, and these formulas you need to have them in your memory, okay? So yeah, so I have to know what to do, and then I can also click this one so not disturbing. Okay, so what we can do is this. Now I want you to tell me what happens if, so let me just write what is on the board. So integral from a to x f of t dt. I try to motivate you that this is actually a function of x. So it means that I can differentiate it with respect to x, and we learn that this becomes simply f of x. Yes? This is what we learned. But now my question is that what happens if a is the same a, but instead of having x, I have a function of x. Any function, not just simply x. So the point is that what happens if I want to answer this question, d dx of this function, from a to, let us say, g of x, f of t, dt. We want to know how can I calculate this. But I hope that you will still understand that this is again a function of x, yes? So assume that f of t, you find a primitive function for that, and then instead of t, you put g of x once, instead of t, you put a, and subtract them. It is clear that at the end what you get is a function of x, so still it is meaningful to ask the derivative of this combination with respect to x. Okay, I don't want you to just memorize the formula, I want you to understand what is going on. So what we can do, I would say that let capital F of x be as defined before, a to x, f of t dt. Okay? And g, of course, by the way, g should be a differentiable function. Okay? Now, if I ask you what is f of 5, what you do, instead of x you put 5, it becomes an integral, you calculate it from a to 5, it becomes a number. If I change my mind and I ask you what is f of 10, instead of x you put 10, integral from a to 10, you calculate it, it becomes a number. Yes? Now my question is that, what happens if I ask you what is f of that g of x? So what do you do? Okay, what you do, you go here, you replace x with what is given to you, which is g of x. So it becomes integral from a to g of x, f of t dt. Okay, is that understandable? So I just replace x everywhere with g of x, I get this one. But this one is exactly the function that I'm supposed to calculate its derivative. Okay, so it means that dx, which is my question mark, d dx integral from a to g of x f of t dt is equal to, instead of this combination, I can write f of g of x, and I have the derivative here, so this becomes d dx f of g of x. Yes? But if I ask you, can you calculate this? Hopefully you know how to do it, because that is the composition of two functions, one capital F, one little g. Yes? So you want to differentiate this combination. Do you remember what was that? This capital F is the outer function, g is the inner function. So you have to calculate the derivative of the outer function, but calculate it at the inner function. Yes? And then you multiply it by g prime of x. Yes? But now if I ask you, how do you calculate capital F prime at g of x, you need to go back to your capital F. Do you remember what was the difference between this symbol and that symbol? This symbol means that first you have to differentiate and then replace x with g of x. So if I want to calculate this one, what I do, I go back, I differentiate the function. So from here, I calculate f prime of x, which is exactly the first fundamental theorem of calculus, which gives me f of x. Yes, and then if I ask you, what is f prime of g of x? This means that after differentiation is finished, I go to my derivative, replace x with g of x. If I replace x with g of x, I get little f of g of x. Yes? And then I put this expression that I got here. So this means that the question mark that I am looking is just f of g of x, but multiplied by g prime of x. So that is the formula I want you to understand. Where is it coming from? And then of course you can use it. Any questions here? So let us just review. If I give you a function like this, a to x, and then ask you to differentiate it, you just go to your function, take t away and put x. But if I have g of x on top, you take t away and put g of x, which is this one, but it is not finished. You need to remember to multiply by g prime of x as well. Yes, is that clear? Okay, so this is the formula for this type. So what do you think about this type? So for example, I ask you, what is the derivative of this integral? For example, from a function which is differentiable, h of x, to another function, g of x, and then f of t dt. So this time, I want to answer this question. Okay? So how can I do that? Instead of this integral, for example, integral from h of x, g of x, f of t dt, I can choose any number. For example, let us consider it 0. So I can go from h of x to 0, f of t dt, but plus integral from 0 to g of x, f of t dt. Yes? But then you remember that I can swap these two, and then the price that I have to pay is a negative sign there. So this becomes equal to minus integral from 0 to h of x, f of t dt, and then plus integral from 0 to g of x, f of t dt. Yes? And now the question mark, which is the derivative of this function, is, because this function is the sum of these two functions, the first one is negative, remember? So the derivative becomes negative of the derivative of the first function plus the derivative of the second function, yes? Yes? Okay, and now if I ask you, do you know how to calculate them? The answer is yes, because each one of them is a derivative like this. Is a derivative like that. So there is a negative sign here, so this becomes negative. What I'm supposed to do, I have to replace t with h of x, becomes f of h of x, but the problem is not finished. You need to remember to multiply by h prime of x, and then plus, do the same thing here. You replace t with g, so it becomes f of g of x, and then you multiply it by the derivative of g. So if I want to write them in order, so first I replace, if I want to answer this, first I replace t with the upper limit, multiply it by the derivative of the upper limit, minus, I replace t with the lower limit, multiplied by the derivative of the lower limit. So that is the general idea of how to calculate these derivatives. Questions? Clear? Okay. So now let us go to an example here. So these examples that we want to solve. By the way, I will put the link to the PDF file below this video on YouTube if everything works fine, okay? So those are the formulas that I mentioned here, but now we want to solve these two examples, yes? So let me write the examples here. Oops, you don't see it. I have to concentrate on a lot of things now. Okay, so these are two integrals. Let me write them and then... I want to calculate the derivative of each one of these functions, okay? So f of x is equal to the integral from 0 to sine x, and then I have 1 minus t squared, and I have dt. Okay, so let's go back now. Okay, so here, if I want to calculate the derivative of this function, so what should I do? I write f prime of x equals to, I go to my integrand, replace t with the upper limit, so this becomes 1 minus sine squared x, but this is not enough. I have to multiply by the derivative of the upper limit, because the lower limit is just the numbers, that's it, yes? So you can simplify this a little bit, so it becomes equal 1 minus sine squared has a better name, which is cosine squared, and then multiplied by the derivative of sine, which is another cosine. So this becomes cosine to the power of 3x. Yes, so that is the answer to this. Okay, let me just give you another example. I don't need to show it up, but because you have already seen that. So f of x is integral from x squared to x cubed, and then I have e to the power minus t squared dt. So you want to calculate the derivative of this function. This function is of this type that we have here, yes? Where I have it here. Because both of them are functions of x. So what I'm supposed to do, if I want to calculate the derivative, I need to go find my integrand, replace t with the upper limit. But I have to remember to multiply by the derivative of the upper limit, minus, I have to replace t with the lower limit, but I have to multiply by the derivative of the lower limit. So let us calculate this. So this becomes what? E to the power of minus x to the power of 6 times 3x squared, and then this becomes minus e to the power of minus x to the 4 multiplied by 2x. So that would be the derivative of this function. Problem from exam. There are two parts, only I consider one part of it. I realize that the improper integrals are the topic of the next actually module, so we will consider it there. But again, this is an exam question. We have the function g of x defined in that way in terms of an integral, and it is defined for all positive x greater than or equal to 0. This should be written non-negative. I don't know if this is my typo or that was in the exam. Determine the number x where the function g achieves its maximum. Okay? So how do you think we should solve that? This here. So again, I have g of x equals to integral from 0 to x, and then I have 1 minus t divided by 1 plus t to the power of 7 over 2 dt. Yes? Okay, the same story, yes? I want to know about maximum or minimum of g function. So the first thing that comes to my mind is to take the derivative of g, but we just learned. This is the simple, actually this is exactly the fundamental theorem of calculus. So what you need to do is just replace t with x. So the exam question is even simpler. Yes? So this is the derivative. And then, is there any singular point for this function? Is there any singularity for g of x? means that is there any point that the derivative is not defined? The derivative is not defined in this case if I can make the denominator to be 0. Okay, can the denominator be equal to 0? The answer is no, because this one, x to the power of 7 over 2, is nothing except the second root of x to the power 7. Yes? And they are telling you that x is non-negative here, otherwise this is not defined in the first place. So it means that no, I do not have any problems here. So the denominator cannot be equal to 0. So I do not have any singularity. But about critical points, yes. I put the derivative equal to 0, so what I get is x equals to 1. Because a fraction is equal to 0 if and only if its numerator is equal to 0. But this is the only candidate. But now you tell me, is it a maximum or a minimum? Is it? Max or min? Min? So how many of you agree? Okay, I want to solve this in two ways. One, the first derivative test. So what you do, so you can write x and then you have g prime here, and then the only candidate is 1. Here the derivative is 0. Okay, what happens if x is larger than 1? If x is larger than 1, this becomes negative, but the denominator is always positive. So the whole expression becomes negative. And then on the left-hand side, when x is smaller than 1, 1 minus x is positive, the denominator is positive, so that's also positive. So this means that this goes up and this goes down, so that is again a maximum point, yes? Yes? But you can also do using the second derivative. You might think that the second derivative is hard to calculate. Yes, you are right, but you really don't need to write all the details. Because what matters is the second derivative to be positive or negative. So what I do, I take a second derivative if I want to. This is one way, the problem is finished. But if you prefer, you can take the second derivative with this trick. So you write this in your head as a product, the product of 1 minus x and 1 over 1 plus x to the power 7 over 2. That's the product. The product of these two is exactly this. So this tells me that the derivative of the first one multiplied by the second one, the derivative of the first one is minus 1 multiplied by the second one becomes this, plus the first one multiplied by the derivative of the second one. The derivative of the second one is a little bit time consuming, but you really don't need to calculate it. You just write it formally. Yes? And then you are supposed to calculate g double prime of 1. So what you do, you go and put x equals to 1. Now you realize actually it doesn't matter. Because this part becomes 0, and whatever this is gone. That's why it's not complicated. Now if I put 1 here, it becomes minus 1 divided by 1 plus 1, which is 2. And then the rest of it is 0 times something. Whatever that thing is 0. Of course, this is always defined, by the way. And then you see that the second derivative is negative. When the second derivative is negative, you just get the same conclusion, that's a maximum. Yes, so it doesn't matter in which way you want to do it. Any questions? Okay. Now let us go to this example. This is also evaluate the following limit. Okay, can you give me an idea? How should I calculate that limit? First of all, tell me what type of limit is this? Question 5.46. Because whenever you want to calculate a limit, you need to see if it is indeterminate form or not. But do you think this particular limit is indeterminate? Yes or no?
Yes.
Yes. What type of indeterminacy is there?
The 0 with the
0 over 0. Yes? It's clear, yes? Because instead of the denominator, if you put 0, it becomes 0. But instead of the upper limit, if you put 0, integral from 0 to 0, from any number to its own, integral becomes 0. So this is a 0 over 0. So it means that Hopital's rule is applicable. Yes? That is very natural here. because we just learned how to differentiate an integral, and Hopital's rule is also related to integrals, okay? Okay, so what we do is this. The limit of integral from 0 to x, 2 to the power of x, 2 power t minus 2 to the power sine t, the whole thing dt, and then divided by x squared, x goes to 0 from the right. Okay, so what I have to do, I have to use the Hopital rule. So I can use, not have to, this is probably the best way. I of course even don't know how we can calculate in a different way, because the first integral is easy to calculate, but the second one I don't have any idea how to do. It might be integration by part rule, but I don't know. So here, if I take the derivative of this one, it is the fundamental theorem of calculus, and it's the simplest possible form. So you just replace t with x. So this becomes 2 to power x minus 2 to the power of sine x, and the derivative of x squared is 2x, x goes to 0 from the right. But still, it is 0 over 0. Yes. If I put 0, 2 to power 0 is 1, sine of 0 is 0, 2 power 0 is 1. So 1 minus 1 is 0, and the denominator also vanishes. So it means that I have to use the Hopital's rule. I can use Hopital's rule once more. Yes. So this becomes the limit, the derivative of the denominator. Okay, now can you remember what is the derivative of 2 to power x? Yes, ln thing, yes. So 2 to a to power x, the derivative is a to power x, the function repeats itself. In the case that a is e, that's the only thing. But in the case of a generic a, I have to multiply by ln of a here. So this becomes 2 to power x, but multiplied by ln of 2 minus, the second one becomes 2 to power sine x, multiplied by ln of 2, but it is not finished. Because of the chain rule, I have to multiply by the derivative of that one, which becomes cosine x. And x goes to 0. Yes. Okay, but I think it becomes 0, am I right? Because if I put 0, 2 to power 0 is 1, times ln of 2 becomes ln of 2. And if I put 0, sine of 0, 1, so this becomes 1. Cosine of 0 is also 1, so it's minus ln of 2 again. And then divided by 2, which is 0. So the limit is actually 0. Okay? Understandable? Okay, so now the next question is actually a very good question. Okay, because a combination of differential equations with actually what we learned here. So let us just read it. A model for a population P of t is given by the integral equation. By the way, an integral equation here, you see that the population function is p, which is not known, but the population function also appears as an integrand of another, as an integrand of an integral. Whenever this happens, that you have an unknown function under the integral sign, that equation is called an integral equation. Because you want to solve and find p. Of course, p also appears here and there, but also appears in the integral. So that is called an integral equation. But you really don't need to know about integral equations. Everything is. So you need to train yourself not being distracted by these words on exam, yes? Even if you don't know integral equation, you don't need to be worried about it. But if you know it. Okay, where t represents time. Number one is actually guiding you. Number one, if you differentiate the integral equation, you obtain an ordinary differential equation of second order. Determine this ODE, this ordinary differential equation. And number two, remember that P of t, we want to determine P of t if the start population, meaning the number of people at 0, is equal to 10. Okay? The second part is actually very interesting. So let us just try to solve this together. Okay, so let us switch back again. So let me write the equation here for you. P prime of t, so the number of people is a function of time. According to this model, the derivative of that function is 2 times that function minus 2 times integral from 0 to t. They have written ps ds because they are not allowed to use the same letter that you use here for this one as well. In this problem, you could also use x, but I think they have done it right. They have chosen something different from x and t. Okay. Minus e to the power of a to the power of 2t. So this is an integral equation. They are telling you that if you differentiate this equation, you will get a differential equation. This is not yet a differential equation, yes? Because you see the unknown function appears as an integral. Okay, so we just do that. I differentiate this. This is the first derivative. When I differentiate it, it becomes the second derivative. And then this becomes 2p prime t. And what happens here? If I differentiate this, what happens? What happens? It becomes 2p of t. Because I have to take the s away and put the upper limit. Yes? And then the derivative of this one is minus 2e to the power of t. Okay, that's it. But you usually, I myself prefer to organize it a little bit. I hope that you see that this is a non-homogeneous second order differential equation with constant coefficients. Exactly what we studied. If I move these two to the left, it becomes p double prime of t minus 2p prime of t plus 2p of t is equal to minus 2e to the power of 2t. Do you remember? It's a second order differential equation, non-homogeneous because the right hand side is not 0, and constant coefficients 1, minus 2, and 2. Okay, now we want to solve this. They have told us that p of 0 is 10. We want to find this function under that condition. Okay, so let us review a little bit. Do you remember what we are supposed to do to refresh your memory? If I want to solve a non-homogeneous second order differential equations, yes?
We start with the parts.
We start with the homogeneous part first, and in the homogeneous part we have the characteristic equations which involves r's, yes? So you are right. So you remember, first you start with the homogeneous part, which is p double prime t minus 2p prime t plus 2p t equals to 0. You yourself put it equal to 0 if you remember, yes? And then what you do, you find the general solution of this homogeneous one. For doing that, I have to write the characteristic equation. Hopefully you remember the characteristic equation of this is r squared minus 2r plus 2 equals to 0. Yes? And I have to solve this equation. This is a simple quadratic equation, so I start solving it. So r becomes negative b, which is positive 2 here, plus or minus the square root of this number to power 2, 4, minus 4 times a times c, which is minus 8, and then divided by 2. But you see that 4 minus 8 is a negative number, so the roots are complex numbers. So that is one of the cases that we have already studied, yes? So this becomes 2 plus or minus the square root of, this becomes minus 4. The minus sign becomes I, but 4 becomes 2. And then I have divided by 2. If I simplify it, it becomes 1 plus or minus I. So these are the complex roots for the characteristic equation. But now can you remember what was the solution? So I would write P, I put an index H representing homogeneous. So you remember what was the solution? So you need to memorize this, yes? Yeah, so do you remember, if I remember correctly myself, I call this K and I call this number omega, yes? and then it becomes e to power kt, exactly, so it becomes e to power t, and then a constant, so let me call it constant number 1, cosine of omega t, but omega is 1, plus another constant sine omega t, which is also 1. So this is the solution, the general solution for the homogeneous part. But then I go to the non-homogeneous part, do you remember? But for the non-homogeneous part, I only need to find a particular solution, yes? And then we learn how to do it, so I need to go back to the non-homogeneous one, but I don't need to find the general solution. I only need to guess one answer, one solution for that. And then we learn the undetermined coefficient methods to actually be able to guess them. So do you remember? So I would say that let us have an educated guess. Educated guess here. So let me put an index P here for particular. It's a little bit unfortunate. So I write this capital P, this little p of t. Okay, can you guess what is a good guess for the particular solution here? Because you see an exponential function, so the first thing comes to mind is an exponential function. Yes. Okay. So I write a number. For example, let me call it capital A, but e to power 2t. You remember when I was teaching, I told you that sometimes you have to be careful. Sometimes you have to multiply by an extra t or even an extra t squared. But do you think we need to do it here? No. Why? Because the answers are e to power t cosine and e to power t sine. But that is not there. So I am on the safe side. I really don't need to multiply by t or t squared. So what I do, I start calculating p prime. It becomes 2a e to power 2t, and I calculate the second derivative. It becomes 4a e to power 2t. And I plug them back into my equation, so it becomes 4a e to power 2t, and then minus 2 times p prime, which becomes minus 4a e to power 2t, and then plus 2 times p of t, which becomes plus 2a e to power 2t. And then it is supposed to be equal to minus 2 e to power 2t. But then you immediately realize they are gone. And this should be identical to this for every value of t. So it means a is minus 1. Yes? So this means that a is minus 1. When a is minus 1, I put it back here. I get my particular solution. Yes? But if I want to write the general solution that I was looking for my differential equation, I have to do what? Do you remember? Yes? Add the homogeneous part to the particular one. So the general solution of my differential equation, it becomes e to power t c1 cosine t plus c2 sine t, and then plus this particular solution, which is this expression. Yes? Okay, still that problem is still a little bit interesting, because how many constants you see there? There are 2 constants, c1 and c2. Yes? So in principle, I need 2 pieces of information to be able to find c1 and c2. One piece of information is actually provided for me here in the problem directly. So let me just use that. So this means that if I replace t with 0, the outcome should be 10. Okay? So I replace t with 0 everywhere, and I expect that the answer, I demand that the answer to be 10. So let us just do that in our head. If I put t equal to 0, this becomes 1. Cosine of 0 is 1, so this becomes c1. And then sine of 0 is 0, minus e to power 0 is 1. It's supposed to be 10. So far so good, because I was immediately able to find c1. But what can I do for finding c2? There are apparently no extra pieces of information given to me. Do you have any idea what to do now with the next one? there is another number that you should be able to guess. I don't know, if you look at the original equation, not the equation after differentiation, you know, there is another number which is also important. So if I go back here, that number 0 also gives me something, because if I put t equal to 0 in the original equation, I will get rid of this term. Yes, and I get something relating p prime and p together. So that's good. So let me go back. So I will put t equals to 0 in the original equation. So this gives me what? If I put 0 here, it gives me p prime of 0. On the right hand side, I will get 2p of 0. But this part will go away, yes? Because when I put 0 here, integral from 0 to 0 is 0. So this will vanish. But this becomes minus 1. Yes? And now you see, p of 0 is also given in the problem to be 10. So when I put it here, it becomes 19. So p prime of 0, even though it was not directly given to me in the problem, I was able to get it by the original equation itself. Yes? And now I have two pieces of information. One piece of information was this one, and the other piece of information I found it myself. So what I'm supposed to do, I have to go back to this function and differentiate it, because the derivative at 0 should be 19. So I take the derivative, it's a product rule here, the derivative of this one, multiplied by that, it becomes the same thing. Yes, plus the first one multiplied by the derivative of the second one, which is minus c1 sine t plus c2 cosine t. And then at the end, I will have minus 2e to power 2t. That is the derivative of this function. Yes? Okay. And then p prime of 0 is supposed to be 19. So I demand what? If I replace t with 0, the output should be 19. Okay. If I replace t with 0, this becomes c1. Yes? If I replace t with 0, that is 1, that is 0, that is c2. Minus 2 is supposed to be 19. Yes? But c1 is 11. And 2, I move it here, so it becomes 21. This means that c2 is 10. Yes? Okay, so c1 and c2, I found them, but in the problem you have to put them back here. So you have to write the answer to be c1 with 11. So you have to put 11 here and 10 here, and that would be your answer. Yeah, so I think that's a good question. It's somehow relating what you learn in differential equations with what you learned here. Any questions? No? Okay, so let me give you a little bit of break so that I can clean the board. I have to remember a lot of things. Okay, so now let us go actually to this question. That is also an exam question. I think that's also a good one, because somehow it is related to the Taylor polynomial of a function which is defined in the form of an integral. Yes? So the idea is whatever you could do with a normal function, you can also do with the function defined in terms of an integral. Okay? So some questions are like this. So I would recommend you, let's just try to solve this problem together, and then we go to the next very important part, integration by parts. So a function capital F of x is defined, as you see, as in the form of an integral from 0 to x of e to power minus t squared. You want to find the Taylor polynomial of order 1 for capital F about x equals to 0, and the second find an approximate value of f of 1/2, which differs by at most 1/8 from the exact value. Yes? Okay, so I think this is not easy for you. So a function is given to you. Capital F of x is equal to e integral from 0 to x e to power minus t squared dt. I am in the first part, I am supposed to calculate P1, the Taylor polynomial of order 1. Yes? So do you remember this is f of, and it is given to you that you are supposed to write it about x equals to 0. So this becomes my function at 0 plus the derivative of my function at 0 divided by 1 factorial times x. That's it, x minus 0. So this is my Taylor polynomial of order 1. This is extremely simple because if you ask what is f of 0, this is integral from 0 to 0, which is 0. And then I have to calculate f prime of x first, but we just learned what to do. I replace t with x, that's it. And then you calculate f prime of 0. F prime of 0 is 1. Yes? And then the Taylor polynomial, p of x, becomes equal. f0 is 0, f prime of 0 is 1, so it becomes just simply x. Probably the simplest Taylor polynomial, yes. So that's the Taylor polynomial of this function. But the second part, they ask you to find an approximate value for this expression. You want to find an approximate value for this. Because do you remember I told you that you cannot find the exact value of this. Because if you want to find the exact value of this, you are supposed to be able to calculate this integral analytically. But I told you that among the functions that we know, normal functions, we do not have a primitive function for this. Okay? So you want to approximate this value. Okay? And I told you that usually in these questions in the exam, when they write some part, they are actually giving you a hint for the second part. So what they in principle means, probably, is to approximate this with a Taylor polynomial. Okay? Of course, I can approximate it with a Taylor polynomial of first degree. I can also approximate it with a Taylor polynomial of second degree. So, but I would recommend you to actually follow what is mentioned in the problem itself. So, but it is not clear yet if I do this approximation, is the error less than 1 over 8 or not? Okay? If you convince me or yourself that if I do this approximation that the error that I am making is also less than 1 over 8, then that is your answer. Yes? But still we don't know. This is our guess that according to the problem, they want us to do this approximation. But to make sure that the error in making this approximation is less than 1 over 8, I have to calculate the error function. Yes? This is P1, so the error function is also E1. Yes? Error function E1 of x, it becomes the second derivative of the capital F. The function is capital F. The second derivative at some point c divided by 2 factorial, and then you write x minus the number 0 to power 2. Yes? If you ask me what c is between a, in this case 0, and x. Yes? This is what we know. But of course I am interested in the error not at any point x. I want to calculate the error, or I want to approximate my error when x is 1/2. So this means that I can write E1 at point 1/2 is equal to second derivative at c, 2 factorial is nothing except 2. Instead of x, I put 1/2 to the power of 2. So let me write it. But now if I ask you where c is between 0 and x, but x is 1/2, so this means c belongs to this. It's between 0 and 1/2. Yes? And if I simplify this a little bit, this becomes 1 over 8 f double prime of c e1 of 1/2. This is my error function, but I have to calculate the second derivative in order to be able to estimate my error. So I go back, I have my first derivative, I need the second derivative. So I calculate the second derivative here. The second derivative of this function is the function repeats itself, but I have to multiply by the derivative of that. So that is the second derivative at x. So this means that the error function at 1/2 is equal to the second derivative at c. Instead of x, I put c divided by 1/8. Yes, divided by 8, sorry. And if I simplify that and take the absolute value, because usually when we talk about the error, we talk about the magnitude of the error. Yes. So the absolute value of this becomes equal to -2 over 8 is 1/4. It is negative, but absolute value makes it positive. I do not need to put absolute value here because c belongs to 0 and 1/2. It's automatically positive. And then I don't need to put absolute value for this one because the output of an exponential function is also positive. Yes? Based on the experience that we got so far, hopefully this will work and this will give me the exact amount of error that I need in this problem. But I have to estimate that error. Okay, do you believe, so first of all, do you believe that this is smaller than 1/8 e to the power of -c squared? Do you believe in this, what I have written is correct? Yes? Because c is at most 1/2. It doesn't reach to 1/2. Yes? So it means that instead of c, if I put 1/2, this becomes 1/8. But then this expression becomes smaller than that expression, yes? Because c does not reach to 1/2. Yes? Is that clear? Okay, and can I say that this is also smaller than 1/8? Why? Because e to power negative c2 can be written as e to power positive c2. And c is a number larger than 0. C is larger than 0, so c squared is larger than 0. So e to c squared is larger than e to 0. So this means e to c2 is larger than 1. E to c2 is larger than 1, so it means that 1/c2 is less than 1. Yes? That's simple as that. So this means that 1/c2 is less than 1, so the whole combination is definitely less than 1/8. So actually what we actually convinced ourselves about is that if I do this approximation, the error that I am making is really smaller than 1/8. And then what you have to write, don't forget to write the question because they are asking you, find an approximate value for f of 1/2. So the answer is what? P1 of 1/2. Approximate answer. But P of x, P1 of x is x, so P1 of 1/2 is just 1/2. So what I'm saying is that we can say the approximate value for f of 1/2 is equal to 1/2, and this convinces us that we are not making an error larger than 1/8. Yes, is that clear? Okay. Now let us go to the next topic. That's also an important one. So the integration by parts. Okay, so integration by parts is actually a trick, a very powerful trick for some particular form of integrals. What for? You have to practice to get some experience, okay? So that by looking at those problems, you find that, okay, integration by part is actually important or useful for this problem. But let me first tell you the theory. So if I give you two functions, u of x and v of x, you can immediately, I can ask you to find the derivative of the product. And you already know the answer. So the answer becomes the derivative of the first one multiplied by the second one. So if you don't mind, let me skip x's. And then plus the first one multiplied by the derivative of the second. Yes? But now I can integrate this relation And I can also integrate this relation, but the integral of the sum of two functions is the integral of the first one plus the integral of the second one. So this becomes du dxv, and then I have dx, plus integral u du dx. Okay, but can you tell me what is the answer to the left-hand side? I am integrating of a derivative. So what happens? This is the derivative of a function. Do you remember if I told you that if you have integral of the derivative of a function, yes? So what happens? It becomes f itself plus at most a constant. Yes? But here that constant can be absorbed here or there. So let us just ignore the constant. So this becomes just what? Ux dx is equal to the, let me just skip these x's. So it becomes uv is equal to the integral. Here you can write v and u prime x dx. Let me write it in this way. So I would say let me write this one first. U, and then instead of this expression, I can shortly write dv, pretending that this is normal fraction, but that is not. So this dv is the symbol that I am using for this. Okay, so this becomes u dv plus the same thing here. This one and this one together, I call it du, and then I have v here. So this becomes v dv. Okay, and then what I want to write, I want to move this to the left-hand side. So this becomes integral of u dv is equal to u times v minus integral of v dv. This is the formula in this form, which is given to you in the atlas, the course book. Yes. So this tells you that if you want to calculate this integral u dv, you can write uv, but minus you can swap these two and ddu. This way, it is easy for me to remember it in that way. So whenever you have integral of u dv, you can write uv minus integral of vd. But let me tell you something. My goal is to calculate this integral. But I am not able to calculate this integral using this formula. I am able, but let me find a good sentence. Oh, the point is that I didn't calculate this integral so far. I have just reduced this integral to another integral. Okay, with the hope that the new integral is simpler than the original integral. So if you ask me, is this formula sometimes correct, sometimes wrong? No. This formula is always correct, but it is not always useful. Yeah? This is only useful when the new integral is simpler than the original integral. Okay? So let me just tell you by starting some examples. So I will go to the next example, example 548. And number 1. So we want to calculate this integral, x e to power x dx. Okay, let me teach you how to think about these integrals. First of all, how should I know that this integral can be done by integration by parts? I don't know how to teach it, but you need to have some prototype example in your head so that you can compare the integral given with one of those patterns in your mind to be able to solve the new ones, okay? Or you can practice a lot to be able to immediately understand it. But of course, even if you practice a lot, they can actually design questions so you get stuck. Yeah, so that's the whole point. Okay, but let us assume that we are able to solve this using this new trick. Okay, so you need to do what? You need to compare your given integral with this one. So here you have two parts. One part you need to call u, and the other part is your dv part. So you have a lot of freedom, of course. Not all of them will work, but one of them probably work here. So you might say that, okay, let us take this one to be u. Okay? If you choose this one to be u, then you don't have any other options. What is left, you have to call it dv. Yes? Yes? So try to follow me just, okay? For the time being, you have to wait to see why this method will solve my problem. And then you will get some experience. So take my word for it. I am telling you, take this x to be u. If you take this one to be u, and you want to solve this problem using this formula, then you don't have any other choice. What is left, you have to call it dv. Okay? And then what we do, so I will start from here. If I ask you what is your u, you tell me that u, I chose it to be x. Is it good or not? We don't know yet. Okay? And then if I ask you what is dv, you will tell me that what is left, which is ex, I called it dv. Okay? And now look on the right hand side. What do I need? To be able to use this formula, I need u. I have it, no worries. But I also need v. Still I don't have it. I need to calculate v. So how can I calculate v? V is the integral of this, ex dx. But can I calculate this? The answer is yes. What is the answer? E to power x. You don't need to be worried about the c. You can put that c at the very end. Okay? It seems that everything is working, but now let us go to the next one. For the next one, I need v. I have it now. But I also need du, which I don't have it yet. So I will calculate du, which is exactly dx. Yes? And then I replace everything here. So I would say the question mark. How do you read the question mark? Integral of u dv. According to the formula is u times v. This is your u times v, which is e to power x, minus integral of v, which is e to power x, times du, but du is dx. Yes? So what happened? I reduced this integral to a new integral. But this integral, I hope that you agree with me, is simpler than the original integral. So I would say this is a good thing we did. Because now if I ask you what is the answer, everyone knows. What's the answer to this integral? Is e to the power of x itself. Negative e to power x. As I told you that you write a constant at the end if you are supposed to find all primitive functions. If they ask a primitive function, you don't need to put c, consider c to be 0. Yes? Let me tell you something else. If in this case, what happened if I had chosen the other way around? Because, let me write with a different color. So this integral is also equal to this integral. Yes, they are the same. But let us see what happens if you might ask, how should I know to take this one to be u? You don't understand it unless you really do it and get a start, to get experience. So let us just do it together here. Assume that I tell you to take this one, you mistakenly, yes? Then, it is inevitable, you have to take this one to be dv. Okay, u is e to power x. When I give you u, you need to calculate du yourself. So du means the derivative of this multiplied by dx. When I give you dv is equal to x dx, you need to find v by integration. So what is the integral of x dx? It is 1 over 2 x squared. Yes? And now let us use the formula. So the formula tells me the question mark that I am looking for is u times v. U is this guy, v is this guy. When I multiply them, it becomes this. Minus integral of v times du. V has a constant, I can pull it out. Then it becomes x squared e to power x dx. So what I get is this relation. Is this relation true or false? False. It is definitely true. But is it useful? No, it is useless. Why? Because I started with this integral. I ended up with an integral with 1 higher power of x. So I'm making the problem harder. So if you tell me, is this equality true? I would say, yes, it is true. But is it useful? No, because I am making my problem harder. I'm reducing, solving this integral to solving another integral, which is even harder than my original integral. So it is important that might be, if you want to use this trick, one choice will work, the other choice will not work. So, okay, so you have to get some experience by solving a lot of exercises that which one will work, which one will not work. Okay? Is that clear? Okay, so now I want you to tell me what can I do for the other one. So that's just, so I want to see how do you feel about the problem. Okay, improve your instincts. Okay. So let me solve the other one. For example. Integral of, sometimes you have to do it more than once. So integral x squared e to the power of 3x dx. I don't know, do you feel that this method, by the experience you got with one problem, do you feel that this method is useful here as well? Yes, that the form is exactly the form that you see there. Okay, so which one do you think it's a good choice for you based on your experience from the previous problem? X squared. So what we do, we say that, okay, let me take u to be x squared, and then the left, you have to choose it to be dv. And then, for this one, you integrate to find v. The integral of this is a third e to power 3x. For this one, you differentiate. Yes? And then you have to remember the formula. So the formula tells you that the integral, how do you read this? This is u, this is dv. So the integral of u dv, according to the formula, is uv, which is this one times that one, minus integral of v du. I multiply v by du. In v I have this factor. In du I have this factor, it becomes 2/3, I pull it out, because that's a constant. And x e to power 3x is left. Yes? So, is it useful or not? Yes or no? It is useful. Because even though still I didn't solve my problem, but hopefully you agree with me, I reduced this integral with the second power of x to a similar integral, but the power of x is one less. So I succeeded to simplify it a little bit. And then, if I ask you what can I do for this one, what do you say? I can use the same trick. Yes, that's the same idea. So what I do, again, I will come here. So if you don't mind, instead of question mark, let me call this one I. And let me call this part J. Okay? And then what you do another trick, the same thing. So you would say that x, u should be x. E dv is e to power 3x dx. From here, I ask you what is du, you will tell me it is dx. From here, I ask you what is v, you will tell me I have to integrate. So it becomes a third e to power 3x. So if I ask you what is j at the end, you would say again the formula, u times v minus integral of v times du. V is this guy, du is this, a third goes out, and then I have e to power 3x dx. But you see, I am making the problem simple, yeah? So this problem is doable. So this becomes, I don't need integration by parts anymore. So this becomes 1/3 x e to power 3x. This becomes 1/3 here is 1/9 e to power 3x. Okay, of course there is a constant c everywhere, but I will absorb all of them into one constant. So what I do, I will take this and put it back instead of j. So the original integral that I am interested in is 1/3 x squared e to power 3x minus 2/3 multiplied by that one. And then I put a constant c at the end. And you can multiply and simplify a little bit yourself. But I think we can do it yourself. Is that clear?
How do you take the value of v?
Pardon? No, whenever I take u, I have to differentiate. Whenever I take the rest of it, I call it dv. dv means the derivative of v. And I want to find v, I have to integrate this. So you see here on the board, so the first one I wrote properly. So when I wrote dv, for finding v, I integrate this. Okay? But because I explained this there, I didn't write it here. So I just did it in my head. Any questions? Okay, let me ask you another question. By the way, sometimes it is very, I don't know, I wanted to write another one. So let me first solve the one which is in the paper. Arctangent of x dx. Okay? So, how can I calculate this one? So this is another type of integral that you have to remember. Integration by parts will be important here. Okay. But if I tell you that this can be solved using integration by parts, I expect you to tell me that which one should I take to be u and which one should I take to be dv. Because there are not that much choices here.
Put a 1 before and make that as u.
So you say that let us write 1 here, yes? Okay, then what do you take u? What do you take as u? So I think that when you put 1 there, your intention is to write u to be 1. Yes? And then the point is that what is left, you have to call dv. So then you write dv is equal to arctangent of x dx. Do you agree? But then that would be the same problem. Because I want to find v, I have to integrate this. So I cannot find that. Because if I could, I didn't even use integration by parts. Do you understand what I mean? Yes.
But I will know this when I do it.
Yeah.
Hopefully.
Yeah. So it is not worth it. Yes? Okay, so let us take this one u, because there is no other way. So I take this one u, and I take this one dv. That's the only one. So what I have is u is equal to arctangent of u, of x, and then I write dv dx. Okay, now let me calculate this. What is du? So you need to remember the derivative of arctangent. If you have forgotten, I can write it for you here. What's the derivative of arctangent?
One over x.
1 over 1 plus x squared, yes? And then dx. Okay, but can you tell me what is v itself? It is this. Still we don't know is it useful or not. Okay, but let us see. This integral is read integral of u dv. According to the formula, let me call it r. R is equal to u times v. U is this guy, v is this guy, I multiply them. But minus integral of v du. V is this, du is this. I multiply them. So it becomes x over 1 plus x squared dx. Okay, then I don't know how do you evaluate? If you say this is true, I would say definitely it is true. But do you think it is useful or not? It is useful if you can tell me how to calculate the new integral. So what I have done so far, I changed this integral from arctangent form to an integral with polynomial functions. It might be simpler or might be harder. If that is simpler, then it is a success, yes? Otherwise, it's a failure. So now, yes?
Is it then possible to evaluate the other integral, x over 1 plus x squared, part by part?
You mean, by the way, I don't know the Swedish name, that is called integration by parts. There's another word in English, by partial fractions, integration by partial fractions. I don't know the Swedish names, okay? So I'm using the English ones. So I don't know, do you mean the same trick here, or do you mean another?
Like, maybe simplifying part by part, like you can do like x squared by 1 over, no, it's because of the denominator.
Yeah, no, if it was the other way around, yes, this is not possible. So do you see that now? Okay. This, by the way, you should be able to do it now. So ln, yes. How do you come to the ln idea?
It's very good. You differentiate 1/2 and then x2 plus 1.
Exactly. So what you are saying, you remember I told you the rule of thumb for these integrals. Whenever you have a function in your integral so that its derivative up to a scaling factor is also there, you need to remember that's a good idea to take that a new variable. But what you said is also correct. But let me try to say this. I will say that for this integral, let me call it j, and I will say that let t, I am not allowed to use u anymore because I have already used that. Let me say that take t to be 1 plus x squared. Okay? Then what happens? dt becomes 2x dx. But here, what I need is this combination, which is x dx. So I divide everything by 2, x dx. Yes? So what happens now? J becomes equal to integral. Instead of x dx, I put half times dt. And instead of 1 plus x squared, I put t. That's exactly what you mentioned. Because 1 over 2 goes out, it becomes integral of 1 over t dt. And this is a very famous integral. The answer is what? As you mentioned, it's ln of absolute value. Don't forget about that. Okay, so that is the ln of absolute value of t. But you have to go back and replace t with 1 plus x squared. Absolute value of 1x squared. But do I really need absolute value here? The answer is no, because x squared is non-negative, so I don't need to write absolute value. So I remove it when I don't need it. So that is the answer to j. So this means that the I is equal to x arctangent of x, yes, minus 1/2 of ln of 1 plus x squared, and then at the end I put a constant there. Yes? Is that clear? Okay, there are some exercises that I haven't mentioned before going to those complicated ones. Let me ask you about these two, okay? So the integral for ln of x dx. Let us just do this one first. So what is your opinion about that? Assuming that we can solve it. So you need to remember these integrals. They are very famous. Okay, so if you want to calculate this integral using the integration by parts, you have only one option again. What that option is? Yes, what is that? Yeah, you take this one u, you take this one d. Okay, so this becomes u is equal to ln of x, so this implies that du is 1 over x dx. And then you take dv to be dx. If I ask you what v is, you will tell me this is x. So if I call this integral I, so the integral I becomes uv x ln of x minus integral, this is u dv, you have to write v du here. But remember, this is v, this is du. If I write v times du, this x will cancel that x. Yes? So it becomes just simply dx. Or if you want, you can write 1 dx because I multiplied. But that is probably very simple one. The answer is x. This becomes x ln of x minus x, but plus the constant. Yes? So that is the integral of ln of x. But now let me solve the problem in this paper. What happens, do you think, if I give you this integral? X to the power of 3 times ln of x times dx. Now this, you might have more than one option. Okay, now I want to wait for you. We can, by the way, we can do trial and error. I want you to learn this is the nature of mathematics. This is not completely straightforward that you can foresee everything. Yes? So, okay, what do you think is a good choice for u? Okay, so you want to take x cubed as what? As u. Yes? Let us check this idea. If you say this is to be u, then
X cubed elements.
but that is not useful. Let me tell you, taking the whole function to be u is not useful. Why? Because if I want to calculate f of x dx, if I take the whole thing to be u and this one to be dv, then what happens for du? Du becomes f prime of x dx, and then v becomes x. So you see it is not useful, because then you will have v du, which gives me x f prime of x dx. So I'm making it a little bit harder. Okay? Okay, any other choice?
ln of x.
To be u? Okay, so by the way, this is better, because if you take this one u, then you have to take this one dv. Okay? If you there are some hard problems that you have to do something like this. But remember, if I do something like this, for calculating du, I don't have any problems. But for calculating v, I have to integrate ln of x, which I just did it. So it means that for that small part, you have to do another integration by part. Yes? So you are making the problem really complicated. So try to avoid that unless it is really necessary. Okay? So if I want to do this, I will not choose this one. Because if I want to do this, then I have to calculate dv. So it means that all solution that you see here is just finding v. And then you need to find another integral. So this is not my first choice. What you said is correct. So in your head, you can reorganize them a little bit. So you can say that I can imagine that this is integral ln of x. And then I write x3 dx. Yes, something like this. And then, as you mentioned correctly, I will take this one u and this one dv. Might be, this is a little bit different from what I started, you know. When I had xex, I told you that taking x to be u is better. Okay? But now I am telling you here, taking ln of x to be u is better. Let us see why. But if I tell you take this one u, by the way, the rest of it you should be able to do it yourself. Okay? So you take u to be ln of x, you differentiate u, it becomes 1 over x dx. But then I tell you that dv is x to the 3 dx. I ask you to find v, this is simple. The primitive function for that is 1 over 4x4. And then the integral r that you are looking for is u times v, which is 1 over 4x4 ln of x, minus, what happens? Integral of v du. V, by the way, you see this is v, this is du. If I multiply them, there is a 1 over 4 factor that I pull out. But there is an x to the power of 4, but 1 over x. When I multiply them, it becomes x to the power 3 and then dx. Is it useful? Now everyone can see that yes, it is useful because the second integral is so easy to calculate. So what I do is 1 over 4, x to the power of 4, ln of x, and this is 1 over 4, another 1 over 4, and this is it. Yes? Okay. Any questions so far? So let me here. Okay, so there is also another problem I have written here. Let me also talk a little bit. I don't know, I haven't seen these kinds of problems in the exam, but this is x times. This time I put the power of 3 not on x, but on an ln. Yes? So we want to calculate this integral now. So what do you think I should do? I would say there is no doubt. If you want to take this one to be u, then you have to take the whole thing to be dv. And I hope that you agree finding v itself is hard. So if it is going to be solved using integration by parts, so there is only one option for me left. Yes. So I rewrite it in my head in this form. ln of x to power 3. This means, by the way, this. Yes. And then I have to write x dx. And then it becomes clear taking it dv. Yes. But let us see how it goes. If I take this one to be u, then you have to calculate du. But du is the chain rule. So 3 goes down, then ln of x to power 2. But I have to multiply by the derivative of ln of x, which is 1 over x. Then I have to multiply it by dx. So this is my du. Yes? And then what happens, the rest of it I have to take dv. And then what is v? Very simple. 1 over 2x squared. And then if I ask you what can you write, if I take this to be r, I becomes u times v, which is 1 over 2x squared, ln of x to power 3, minus v times du. So what is v times du? This is your v. This is your du. If you multiply them, what happens? There is a 3 here, a 1 over 2 here. It becomes 3 halves. I pull it out. Then the integral. This x squared that you see here will cancel that 1 over x. There is 1x left. And there is dx left. And then I have ln of x to power 2. Yes? Okay, do you think what I did was useful or not?
Yeah.
It was useful. Why? Because if I ask you, how do you evaluate this resultant integral, you see that you can compare it with the original integral. It's exactly of the same form, but the power of ln is reduced by 1. Now I think you understand what is going on, what I'm supposed to do. If I do this trick once more, the derivative of the power of ln will go 1 down, and then if I do it one more, I get rid of ln at the end, and I will be able to solve that. Yes? Instead of doing it in this way, I want to teach a little bit different way. Okay? So you can continue yourself. So you need to do this two more times, and then you will be able to solve the problem. But there is also some problems like this. Instead of this one, let me consider integral x ln, not to power 3, to any power, dx. And let me call it integral which depends on n. So let me write it by n. Yes? And I do the same trick. So I will take this one to be u, and this combination to be dv. Yes? So then it means that u becomes ln of x to power n. If I ask you what is du, n goes down, ln of x to power n minus 1, but I have to multiply by the derivative of ln and then multiply by dx. And then the next part, I will take it as dv. And then what is v? v is 1/2 x squared, yes? And I write the integration by parts. In becomes equal to u times v. This is u, this is v. If I multiply them, it becomes 1 over 2x squared, ln of x to power n, minus integral of v times du. v is this guy, du is this guy. What was that? This was n. If I multiply them, n from here and 1 over 2 from here goes out. And then this x to power 2 will cancel one of these x's, so it becomes x here. Then it becomes ln of x to power n minus 1 dx. Okay, let me wait. Is that understandable, what I have done? Yes? I have put them in the formula. But now something interesting happens. If I call the name of this integral I with n as an index, it is, what can I call this integral? Can you tell me? If the name of this integral, I call it in, that is the same integral, but n is replaced by n minus 1. Is that understandable? So I can call this one I sub n minus 1. So it means that In, I couldn't calculate In, but I found a relation between In and the previous power. This is called a recursive relation, yes? So this becomes x squared ln of x to power n minus n over 2 In minus 1. So I didn't succeed to solve this, but I was able to find this formula. Is that clear? But now, can you tell me what I'm interested in? The original integral that I am interested in is I sub 3, because the power of ln is 3. So what I want to calculate is I3. Do you agree? Okay, so it means that I put n equals to 3 here. What do I get? I3 becomes 1 over 2 x to power 2 ln of x to power 3 minus 3 over 2 I2. Yes? And then, instead of n, so I3, that is my question mark, is related to the previous one, which is I2. But now if you ask me what is I2, I go back to the formula. Instead of redoing it again, I put 2 instead of n. So this becomes 1 over 2 x squared ln of x to power 2, 2 over 2, which is 1, but I1. Yes? And if I ask you what is I1 then, I1 is 1 over 2 x squared ln of x to power 1. But if I put 1 here, this becomes 1 half I0. Yes? So I don't need to do the calculation over and over again. I found it recursively and I can repeat it. But if I ask you, can you calculate I0? The answer is yes, because I0, instead of n, I put 0, so this becomes simply x dx. Yes? Because if I put 0, it becomes 1 x dx, which is 1 over 2 x squared. Okay? So I put it here, I find I1. I put it here, I find I2. I put it here, I find I3. That's a way of doing it. So I want you to know this trick as well. But of course, if in the exam this is given, it might be better for you to do it 3 times. Okay? I haven't seen that they have given so high power there in the exam. Any questions? Okay. So I think we have to stop here. And next time I will start with other exercises here, and then we also probably should finish the Riemann sum and how to use the Riemann sum to calculate some limits. And then this module will be finished. Okay? Any questions? Okay, thank you very much.